Okay, see, very basic question. I'll start here. I'll take like this. A, B, C, D. Okay. When you draw this jointed rod problem, important note this, don't joint rods like this. See my diagram I shown here and here how leave a gap between the jointed. Very useful, otherwise confused when showing the forces, right? So here I shown four equal rods in length. Also their weight is W, which is suspended from A somewhere here to the ceiling over horizontal beam, something like that. So then forces there, I'll ask some question, we'll work together, right? So draw this diagram, draw a neat diagram showing this rods A, B, C, T. Then right below, as shown in the figure, four uniform rods AB, BC, CD and AD. AB, BC, CD and AD are smoothly hinged jointed at their ends and suspended from A. If the weights of the rods are W, and the length is 2A, the weights of the rods are W and the length is 2A, weights are W, right? Right, find the force or find the horizontal and vertical components. Find the horizontal and vertical components at the joints B, C and D. Find the horizontal and the vertical components at the joints B, C and D. And also, second part or the part, and also find the tension on the string where is suspended. Find the tension on the string where the framework or where the frame suspended. Right, another important part I don't mention here, where BAD angle to theta. BAD angle to theta. Okay, will work now. See, simple. So I create this problem. basically it's the starts case, starts day, or starts problem, start lesson. So see how I'm showing this. All the static means what? Forces. Dynamic is motion. So in the motion you have to show clearly the acceleration, velocity, also few forces. But here completely forces. The force diagram therefore important, right? See how to show the force diagram in this case. See, very first we mark the weight, always weight egg downwards. Weight egg downwards, vertically down. It's set W, midpoint W, and here W, the same comes here W, right? All these forces vertically down W. I said the length is two-way length of each rod, therefore here A, here A, here A, okay, A, all same, right? Okay. Next, you know here tension force is tied from that horizontal beam to the beam. Therefore, there's a force called T, right? Tension. And what are the next important part? Jointed rod means we research or we consider the equilibrium of the each rods. Therefore, see, if I mark here, that side here is X, the force X, right? So opposite and equal here another X. Here X. And here vertically if I say Y, downwards here also Y. Okay. So Navaratna, you know this, what is Y value? I mentioned my note, Y is 0. Y is 0, right? Because this is the parallel symmetric line. This is symmetric figure. This is AC symmetric line. In jointed rods, any force is parallel to the symmetric line, that is becomes 0, right? This becomes 0. I will show, I show by some calculation method also. Here Y. Come here, this joint, baranda may joint take. So this is I show X that side. So here I show X is this side. Okay, no problem, wherever, whatever. But answer comes minus, no problem. It's not a wrong answer. That theoretically it's correct, right? Numerical number value only near minus plus, but the answer correct. Modulus value is okay. I took Y down, so here I say Y is up. Okay, here Y is down, right? So same force C Shihara, same force B at D. මේ වගේම තමයි මෙහෙත් තියන්නේ. Okay, so draw this system. And also I said the angle 2 theta, symmetric diagram, therefore sides are equal, theta theta, right? Theta theta. The same comes down also. Length of the rods are equal. The answer, it won't comes the A where they all cancel. The equal lengths are cancelled. The answer comes in some term theta, in terms of theta and W. The reactions at the each rods. So how the B, the same at D, and because of symmetric diagram. So C, at the C, the X there, Y becomes 0. I mentioned my note, every jointed rod problem has to decide which is parallel framework. then any force parallel to the symmetric line is 0. So here this is AC, AC symmetric line, okay, right. Okay, come back to the answering here. I said my first note, y is 0. Now see, I will show how the y is 0, right? There are two methods. See this. This is a symmetric diagram. This is a symmetric diagram. AC is a symmetric line, right? AC is a symmetric line. See here, for equilibrium of the joint C, for equilibrium of the joint C, here y downwards, here y upwards, okay, y downwards, y upwards, that's the force because of satisfy the Newton. For satisfy the Newton's opposite and equal, that theory, here up, here down, no problem, that's correct. But we said AC is a symmetric. So what do you mean symmetric? You know, parabolic shape, symmetric here a point, here a point, here a point, here a point. So if this is a mirror, so by symmetric about that mirror, if the arrow up, here also arrow up, arrow up. Or if you show arrow down, that's called symmetric. But in this case, see, arrow up, y down. It cannot be symmetric na make uda tiyantone. If it's pallaya na make it pallaya. It cannot be, it's impossible here therefore. Satisfy the Newton, it's okay. Opposite and equal or down. Up and down to satisfy the person called Sir Isaac Newton's that opposite and equal, therefore equilibrium. Up and down, it's okay. Okay. But by symmetric, this is up, this is down. Therefore symmetric is failure. Symmetric, if it's up, here up. At some point in parabolic shape, you learned all your mathematics. Here a point, or here a point, here a point. Then that's called real symmetric, no? Therefore, Newton's that case is okay. Opposite and equal is okay. But same direction should be here, ne? That's the meaning of symmetric. But here impossible. Therefore, to satisfy only solution, y should be 0. Y should be 0. No harm, no matter whatever, up or down, no matter, y is 0. That's the meaning of parallel line. If any force moves parallel to the symmetric is 0, right? That's I explained now one method. That is we call theoretical or argument method, discussion method, oral method. The other one by take the calculation method, we'll see later. Now I show this also. So write this. The framework ABCD, the framework ABCD is parallel about the vertical line AC. Is parallel about the vertical line AC. Is parallel about the vertical line AC. Therefore, at the joint C, the vertical force Y, should be same direction for each rod. Should be same direction for each rod. Should be same direction means what? This is up. Here also should be up. Or down means because symmetric you want. So the up down means down, right? Should be same direction for the each rod. Let me I mark for this rod and this rod, right? Don't join the rods, otherwise confused. Leave a gap, always leave a gap, especially in this chapter. Should be same direction for each rod. Right, next. But for satisfying the equilibrium, it should be equal and opposite. it should be equal and opposite. It should be equal and opposite. Therefore, to satisfy these two above conditions, to satisfy the above two conditions, y should be 0. Y should be 0. Y should be 0, right? Very important method. You can write the exam paper scheme by symmetric y is 0. So I shown how it's possible, right? How it's possible. Now I show you another method. Now I show you another method by show you another method that is by collecting equation, right? Okay, that's the main issue in the static problem, equations. Okay, now see the main issue of calculation part. So remember one thing, jointed rod problem, very clearly we will study about the taking moments, resolving forces. That's the main issue in the jointed rod, right? Very clearly we can improve our knowledge of taking moments. See, and now what the question ask, what the problem I ask, very first T, the first T value I ask, or the forces, reactions at B, C, D. What do you mean resultant? Resultant force or reaction mean what? You find the X and find the Y. Find the X and find the Y and put the square root. X square plus Y square square root, right? The same comes D also. So if you come to here, there's a small error here. But we say here x1 because here xy there, here x1, here y1, here y1, right? Here, but the result at C, find the x value, find the y value, put the square root, right? But you know y is 0. So what is the x is the answer. Okay, now I show you by calculation method how to find the y value becomes 0. Also find the x value. Here come x1 value and find the y1 value. Okay, easily we complete the T answer. How to find the T answer? The tension in the suspended string. How to find the T answer? For system, if you for the system, resolve upward. For system, what do you mean system? Then there are no joint, opposite and equal forces are 0. System, opposite and equal forces are 0. Opposite and equal forces are 0 for system, right? Therefore up is T, down is 4W. So you can find the T answer. So write that for system, show vertically, resolve vertically up. For system, resolve vertically up. For system, resolve vertically up. What is that? T equal 4W, okay? That's the tension, T equal 4W. For system, resolve vertically up. That is T equal 4W, okay? T equal 4W. Right. Now come back to the find the X value, Y1 value, those things, right? Now see some angle I show you. Here 2 theta and a theta, They are also the same, right? By symmetric diagram, right? Okay. Now see, I will show once again how y becomes 0, right? See, take BC, take rod BC. See, take rod BC, take moments about B, right? For rod BC, take moments about B. You know moment, force into distance. So if you for rod BC take moments about B, what are the forces comes? X and Y and W, right? X, Y, W. X and Y are two unknowns, W is known. You have one equation. The same fashion, come to CD, come to rod CD, come to rod CD, take moments about D, take moments about D. What are the forces? X there, Y there, W there. Again X, Y, W. Another equation. Then you know two equations, two unknowns, solve and find the both. That's the meaning, right? Next write. For equilibrium of rod BC, for equilibrium of rod BC, takes moment about B. Take moments about B, huh? So write the B, show any direction. Can I mark this X pettadamuda, X, that is what we call counterclockwise, other one anti-clockwise, ne? Okay, like this, show your static knowledge. Moment, force into distance is a moment, right? So what the force? X, force is X. What the distance? Vertical distance. What is this? Is the line of action. Okay, this, what is that? Here 2a cos theta no? 2a cos theta, right? 2a cos theta. X into 2a cos theta. X into 2a cos theta. Okay, this direction. How the y comes other side, ne? Make okay, minus y. What the direction? This is the force line of action. So this horizontal. Here 2a cos 2a sin, ne? Here 2a sin, right? 2a sin theta. 2a sin theta. Okay. I took the rod BC. What is next? What the force? W. Next force is W, right? Next force is W. What is the direction? See, W, very important in this chapter only. You can clearly identify the idea of the moments. If you fail this moment problem here, I have no chance. So, uparima ideas ganda moments kohomada. Take W, this like mehma W. So this direction, I think Y and W same, huh? Okay, plus W. What the distance? This one, this here. So here theta. So a sin theta, ne? A sin theta. Okay, A 1a, not 2a, yeah? W half. W at the half, ne? A sin theta equal to 0. Okay, is the method, right? By taking and obtaining a first equation of these four rod moments. Now see, the majority, sin theta is the majority. So can I divide by sine? And also divide by, I mentioned A okkum enne uttara cancel venawa divide by sine, huh? So what is that? 2x cot theta minus 2y. Can I take the W other side? Minus W. Okay, say your first equation, right? First equation. So here I'm showing once again how y becomes 0, right? Now come to CD. Next, write for rod CD. For rod CD, takes moment about D. For rod CD, takes moment about D. For rod CD, take moments about D. For rod CD, take moments about D, right? It also show this x direction, x direction, right? So that side, okay. So what is moment? Force into distance, right? Force into distance. Force is x. Force is x. Okay, force is x. But the distance, vertical distance here, vertical distance, what is that? 2a cos theta, right? 2a cos theta. Up to here, distance 2a cos theta, ne? 2a cos theta. 2a cos theta. Y also same, ne? Y also same, that sense direction, right? Plus y, plus y, plus y. What is distance? 2a sin theta, 2a sin theta, right? 2a sin theta. 2a sin theta. Okay. Next W, how the W? How the W? Direction, how take this? If you're confused, take somewhere, move up, move the line of action up, and see W comes that side, that side. That means opposite, opposite, right? W arrow down, wide arrow up. W arrow down, wide arrow up. So downwards, downwards, right? Minus W, okay. Minus W into what is that? A sin theta. A sin theta, okay. Equal to 0, right? Now here also similar fashion, cut by sin theta, cut by sin theta and A. Cut A and the sin theta. That is 2x cot theta. 2x cot theta plus 2y, okay, equal to W, right? Say second equation. That's all here, applied maths for to find the x and y. Solve this pair of equation. Solve this pair of equation, find the x value and the y value. Hence you can find the resultant force at the joint C. So can I add the both? Add these two equations, 1 plus 2, 1 plus 2, add the two equation, 1 plus 2, what happened? 2y minus 2y cancel, 2y minus 2y is cancel, 2x, 4x, ne? 4x cot theta, 4x cot theta equal to other side W and W. Is it okay? 4x, okay. Right, I add the both. Something missing here, see. X, that's here, X, that side, why no problem, W. I talk about this moment about the B. See this W here, W problem. X that side, X that direction, W this side, see, W this side, okay, W minus, see here, W minus, first equal wrong, W minus, so here plus W. See properly, otherwise said no. In this chapter only we are studying clearly. In this direction only that we are studying clearly the moment ideas, right? So therefore if we have 2W, 2W, right? 2W. Therefore what we call x equal W by 2 tan theta, W by 2 tan theta, W by 2 tan theta is the x answer. 1 added 2, 1 subtract 2, 1 subtract 2, 1 subtract 2, what is the answer? 1 subtract 2, x cancel, y minus y, 4y, ne? 4y is 0. See, I shown you today two methods how the y becomes 0. Two methods how the y becomes 0. One is discussion oral method. Other one is by solving equation method. If there's a symmetric line only is possible, right? In a framework, if there's a symmetric line, the force parallel to the symmetric or the reaction parallel to the symmetric is null, 0. I shown. Okay. So you know x answer, you know y answer. Next I ask, but the resultant at XC, but the resultant force at C, but the resultant force at C. Therefore, write, therefore, resultant at C, resultant at C, resultant at C, that is X. Usually, resultant is what? Square root of X square plus Y square. Here, Y is 0, therefore, X only. Resultant at C is what? W by 2 tan theta. W by 2 tan theta. That's the resultant at C. Resultant at C, W by 2 tan theta, right? Okay, so very useful the first question. You can study basic all the ideas of jointed rods here. Next I ask, but the resultant at B, same as D, yeah? Same as D, right? By symmetry, how the B, I not show here. මේ මෙතන force එක දෙන්න නැහැ. අරකමයි මෙතනට එන්නේ මෙහි x1 කිව්වොත් here also that side x1. Here downwards y1, then here downwards y1. Okay, now we come to how to find the x1 and y1, right? How that x1, y1 for this system. See the rod BC, x1 this side, x that side. Only the horizontal force is x. So can we resolve that one? X this side, x that side. X1 this side, x the other side. So what happened therefore? Horizontal forces are equal. So you can find the x1 answer. Right, next. For rod BC, resolve horizontally. For rod BC, resolve horizontally. This side x, this side x1. So no doubt, x equal to x1, right? X equal to x1. So what is x1? Answer therefore, W by 2 tan theta. W by 2 tan theta. That's the answer. X1, right? And next find the y1 answer. That means vertical component and the hinge B or the joint B. How that? The same method vertically. Resolve vertically upwards. Resolve vertically. Resolve for rod BC. For rod BC, resolve vertically upwards. So what are the forces? Y comes down. Okay, and according to my method, y comes down. I put up ne. Here y1 up ne. Therefore y1 up minus y. Okay, minus w. Don't miss the w. Equal to 0, right? Vertically resolve. The force vertically. Y1 up, y down, w down equal to 0. You know y is 0, neither. Y1 answers w. Y1 answers w. Then come to the reaction at B. Therefore, reaction or resultant reaction at B. What is reaction at B? Square root of x1 square plus y1 square. So square root of what is your x1? W by 2 tan theta, all things square. What is your y1? W square. So simplify, take the w out. It becomes 1w outside, w square. What is inside? 1 over. Can I take the 4 also out? Take the 4 also out. W by 2, right? Tan square theta plus 4, is it? Tan square theta plus 4. I took the w and by 2 out, right? That's the resultant force at B. Same force at D, right? Also I ask the additional problem. Find the angle. Okay, in 1 minute it will off, we'll reconnect. Find the what you call the angle. They ask find the resultant at B and its direction. Find the resultant at B and its direction, its angle, right? See how to answer that one. Angle. So if I come to the point B, I show point B. According to my method x1, here I found that if I take 1 y1, that also both are positive now. Okay, see this, and this is the resultant, right? Resultant. Can I write this angle is alpha? Then they ask resultant with the horizontally or with the vertically. That's the method, right? Put tan alpha. Tan alpha equal what? Write the tan alpha value and find the answer. Tan alpha value, what is tan alpha? The YouTube viewers, opposite side, adjacent side. Then write the tan alpha. What is tan alpha? y1 over x1, right? Tan alpha is y1 over x1. Then write those values. So let's see, what is your y1? That is w over, what is your x1? W by 2 tan theta, right? W by 2 tan theta. W by 2 tan theta, right? Therefore the answer W cancelled. 2 over tan theta. Therefore alpha equal tan inverse. Alpha equal tan inverse. Alpha equal tan inverse, right? Is the method if they ask the reaction at B or resultant makes with the horizontally or vertically, such question. This is my first question here in this session. Jointed rods. I send the tutors will work that. Okay, see another problem, another question. Next question. Write the problem. A triangular framework. A triangular framework. A triangular framework. ABC. A triangular framework ABC. Made by joining smoothly the ends of 3 uniform rods. The ends of 3 uniform rods. The ends of 3 uniform rods. Comma, each of weight W, and the length is 2A, and the length 2A, and length 2A. And length 2A, and length 2A, comma, is suspended freely from the joint A. is suspended freely from the joint A, is suspended freely from the joint A, full stop. Find the magnitude and the direction. Find the magnitude and the direction. Find the magnitude and the direction of the reaction at B. Of the reaction at B on AB. Reaction at B on AB. Reaction at B on AB. Okay, and the simple. Always the exam will work now. They know I at 2020 question. You can answer yourself simple ideas. Okay, my second question. So draw diagram, mark the details and calculate. So in this case I said triangle the shape. This is BOA part problem with the framework. This is a heavy rods. The syllabus is heavy rods and right rods. There are two questions come, A part, B part. This is one part of that. Other part is light rod called framework. The Bose notation. They are called Bose notation. Okay, draw the diagram. Triangular framework ABC. A triangular framework ABC. You know ABC like this. If I say A here, B here, C here, right? ABC framework smoothly join their ends, and the framework each weight W and the length is 2-way, right? Weight is W, length is 2-way, which is suspended from A. Suspended from A. That's all. Draw diagram. I said don't join the rods. Don't show the joints. Leave a space, leave a small gap. Then only very clear, otherwise confuse. Here I mention A, here B, here C, right? A, B, C, okay? A, B, C. Length is W, each weight is W, length is 2-way, right? Yes, find the reaction at B on AB. Yes, we'll see questions how they are asking the method of pronunciation. Every problem is a different style they pronounce it. So they said the word form, they use terms, but finally the idea is same. A, B, C. Okay, weight is W, ne? So show the weight W. W. This is symmetric figure, the equilibrium equilateral triangle. This is equilateral triangle because length are 2-way, 2-way, 2-way. Their angles are 60 degrees. So figure is symmetric, yes. Figure is symmetric. This is A length, here also A, here A, here A. So if you know some geometrical skills, in this case, W should be passes through this. W should pass us through A, right? Here the suspense AT is the diagram. Here no any forces or reaction forces passes through the symmetric line. There's no any forces passes through the symmetric here, right? Therefore you can't say Y0 and you can't say W is 0. There is light rod. W not 0 in this chapter. So here no reactions passes through the symmetric line, right? So T available. Or you can take some poses here. Here they are, here it's a joint here and that side. In that case you can consider that one. So what is the question here? Find the magnitude and the direction of the reaction at B. At B on AB. Same as on AB on BC. On AB on BC. Same method. So because here x, here y. So same on AB. AB mata kriya karna react forces. නැත්නම් BC similar fashion. Okay. If they ask T, what is the answer? Vertically resolve. T up 3W, ne? T equal 3W, right? T equal 3W. Okay. Now I show the forces act in the each joints. So come here. If I mark horizontally x, here horizontally x. If I mark upward y and downward y, don't join the rods. If you not join only, you can show clearly the forces, right? And very important, another one, angle 60 degrees each. Yeah, angle 60, here 60, very important here. Then here 30, right here 30, here 60, okay. That's all. It is a simple question, not like the earlier one. The problem is find the x value and the y value and put the square roots of x square plus y square, right? That's called is resultant, or the resultant act B on the rod AB. That's the meaning. So try to get some pattern to find the x and y. So how the method? This chapter we move using a lot of moments, ideas, or resolving forces pattern, right? So you can find the y answer. Always think a simple method. Timing important. Quickly you can work and you can earn a lot of marks in these problems. So see this for rod BC. Can I take moments about C? For rod BC, take moment about C. Then you see x passes to C. You know moments principles. X passes to C. Force is available, distance 0. Therefore x, that part 0. Moment about C, for the force x 0, y 0. Force is available, distance from the line of action to C 0. Therefore overall they are 0. So you have the y answer only. Simple. So write this. For rod BC, takes moments about C. For rod BC takes moments about C. For rod BC takes moments about C. So show the C, and can I write this direction y like this, y into 2a, right? Y into 2a. W also downward ne same ne, plus W a, yeah? A half length is a equal to 0. Therefore a cancel, find your y answer. What is y? Minus W by 2. So no problem, minus. Don't think you can because y comes up there. For actual y is up. That is common sense. See W down na. Okay. So in the exam full marks, no matter about the minus symbol. So minus shows you where the direction. So y is W by 2. But we mentioned we should consider our answer. Don't say plus W by 2. Here minus ne. Ekamai arang yantone. Now find the x answer. Take a method to find the x answer. But the method, think of simple methods. For rod AB takes moment about A. For rod AB takes moment about A. Rod AB takes moment about A. Then x there, y there, w there. You know x, find the y. The interesting question is if you for rod AB, for rod AB take moments about A. For rod AB take moments about A. moments about A. Can I write the x down, x better than x? Okay, x this anti-clockwise, counter-clockwise, x better, x direction. Okay, that. So what is for moment? Force is x. Force is x. Line of action, duram echara. What is that? 2-way cos theta, right? 2-way cos theta, right? 2-way cos theta. 2-way cos theta. Y is other side. Y other side. Okay. Let's go this side. Y comes opposite, ne? Minus y into. This is 2-way cos. Other one 2-way sine, right? This one. The 2-way cos theta, 2-way sin theta. Okay. 2-way sin 30. Or theta means 30, huh? Here 2-way. I said x. This x. This one. 2-way cos 30. Okay. 2-way cos 30. And here 2y sin 30. Okay. 2-way sin 30, right? How W? The same direction, huh? W same direction, check will you? W same direction, like x1 W here. If you don't know problem, you produce to upward line of x එතකොට ඇද ගන්න දිගට උඩට ගන්න එහෙන් ඉඳලා බලන්න මේක අපිට මේ පැත්ත මෙනවා ඇති. Okay, towards A, the direction that I took, right? So minus, okay, plus W, but the distance is much. Totally 2-way, therefore A sin 30, A sin 30, yeah? This is A, yeah, A cos 30, A sin 30, right? W into A sin 30, right here. W into A sin 30 equal to null, 0. That's all. So therefore majority sign, divide by sin 30, divide by sin 30, divide by sin 30. Also got the A, ne? 2x cot 30 minus 2y minus W. Is it okay? Divide by A, cut by A, cut by sin 30, cos divide by sin cot 30, and minus 2y, and that side 30 cancel, minus W. You know y answer, put here, find the x answer. So 2x, what is tan 30 root 1 over root 3, ne? Cot 30 root 3, huh? Can I say 2 root 3x? 2 root 3x, okay. Minus what is 2y? What is 2y? You don't put y for w by 2. Y is w by 2 is wrong. What's your w? Your y answer apply. I think my y answer w by 2 minus. Therefore it become plus here. W 2y is w, 2y is w equal to minus w. Therefore what's your x answer? Simplify will you? Minus 2w over 2 root 3 there. So x answer minus 2w. Check will you, that is. So 2 cancel, 2 cancel. Therefore x answer is what? Minus w over root 3. Minus, no problem. That is shows you where's the direction. So what the question here, find the magnitude and the direction of the reaction at B on AB. That means they ask find the x and y and resultant, right? X and y and the resultant. Also direction mean angle. Tan theta දාන්නේ අපිත් මම පෙන්නුවේ earlier. Therefore, right, therefore reaction at B. Therefore reaction at B equal to what? Square root of x square plus y square. square root of x square plus y square, right? Therefore apply the values. Square root of what is x square w square over 3. Here no minus problem squaring. What is y square? What is y square w square over 4. Okay, now simplify, get the answer. That's the reaction at point B, right? So LCM is 4, 7. So what the answer if I take up, down, 7, the 7 over 12, is it W, ne? Root 7 over 12, you can take the 12 also 4 times 3. You can take 4 times 3 kattama, there's an answer. Root 7, 4 times 3, 2 root 3. Like this, W root 7 or completely W by 2 root 7 over 3, right? That's the reaction at the B. Also they ask the direction. What is direction? Means angle, sin theta, cos theta, tan theta angle. But most 90% we use the tan theta. So therefore draw a rough diagram and mark those things. So in my view, x is just there, y is here. We write our values. So they not say any horizontal, vertical, magnitude and direction of the reaction only. So therefore I take this is theta. Okay, what is tan theta? Opposite y, x. See, both are negative. So no problem, minus plus, right? So tan theta equal, minus x minus y. Okay, no problem, minus cancel here. So write your x value w over root 3 and your y value w by 2, w by 2. So what the answer? Theta equal tan inverse 2 over root 3. Theta equal tan inverse 2 over root 3 with the horizontal. So this is that question. We'll see another problem. My third question. So interesting, very easy. We'll see 2020 Arilesima paper applied and pure both. Simply you can take answers of that. Okay, write this question, my third problem. Write this: two uniform rods AB and AC. Two uniform rods AB and AC. Two uniform rods AB and AC, each of weight W, end of equal length, are jointed smoothly at A. The system is placed in a vertical plane. Such that B and C are on a smooth horizontal plane. And midpoints of the rods are joined by a light inextensible string. joined by a light inextensible string if angle BAC equal 2 theta, if angle BAC is 2 theta, find in position of equilibrium, the tension in the string, and the magnitude and the direction, at A on the rod AB. Okay, see, will you this question? So very useful. Every problems are useful if you identify my methods, my explanation. Simply you can get the A pass. Getting my A pass is very easy. So next this night you have lesson. A special timetable all over the other classes. So today this evening we'll work that I finish the maximum minimum, right? And I start the integration next day. So 7 to 9, you know the time, I think. Okay, see this diagram and complete it. Diagram. Two uniform rods AB and AC. So AB and AC, there's A is the common point, ne? Base W, equal length and join smoothly at A. The system is placed vertical plane. This is the system. This is the plane, vertical plane. So this question, the B here, ne? B is AB and BC, right? AB and BC. A here. AB and AC smoothly joined at A. The system is placed in a vertical plane such that B and C are on a horizontal ground plane. So draw diagram. BC and here A, like this. Their weight is W. For equilibrium, they said, and the additional part, they're joined by their midpoints like through a string, by a string. You know, this is the midpoint. Here the midpoint. So here they joint tension W, right? Here weight is W. This was string for equilibrium. Sometimes it will collapse. Therefore, for tighter than a string again. Actually, the use of string should be thrust. So it will be pushed both sides. But there's tension something. Therefore, we show the force tension. You know, tension arrow. Tension comes like this. There are two types of forces, tension and the thrust force. Both we call stresses. Tension and thrust. Here they are tension, therefore arrows onwards towards each other, right? Towards each other. Okay, next one. Can I mark here horizontally X? Here horizontally X. Vertically Y. Upwards I said. Here down Y. Here horizontal plane, smooth, there's no friction. That's why they use smooth or uniform. So in this case, no friction available, right? What are the forces hereafter? The reaction exerted by this, the flow or the ground or the surface gives reaction. This is a symmetric diagram because two-way length. Also there's the angle BAC 2 theta. The angle 2, therefore theta here. That is an isosceles triangle. Okay, isosceles triangle, symmetric. Therefore, can I mark the reaction here? Yes, see, very important. First time I am showing here vertical reaction. If I say this is R, here also R, right? Here also R. This is the force diagram. Complete force diagram is this. Okay, the question is find the tension and direction at A there, no? So you have to find the X value and the Y value. See this, I start symmetric diagram, therefore Y is 0. Because symmetric axis, this is the symmetric axis. For this axis, Y is the parallel force, Y is the parallel reaction. Therefore, Y is 0, or otherwise by solving equation also you can prove, but not necessarily the scheme. Right sentence. Bisymmetric, Y equals 0. Bisymmetric, Y equals 0. Bisymmetric, Y equals 0. Bisymmetric, Y equals 0. Okay, next we find the X answer. The question is find the X value and the T value, that's all, and the direction also. Okay, now think about if you come the X answer or T, how that everything take the moments idea, right? Moments. See, for rod AB, so they would ask the R, you can find the R, no problem. For system, if you want for system, what do you mean system? Opposite and equal forces are vanishes. It won't come for system, right? For system, if you horizontally resolve, vertically upward resolve, but R, 2R equal to R, 2W, okay? 2W for system. Therefore, R equal to W. Study this for system. When you apply the system, opposite and equal forces vanishes. So here R, and W, T cancel. Here X cancel, Y cancel, right? Therefore, you know the R answer, R is W. Then simply you can find the T answer. They ask find the X value, Y value, T value. So how that? See, for rod AB, can I resolve horizontally? Shall we resolve horizontally? This side, X equal to T. X equal to T, see? An important equation, X equal to T. Okay. Right. Now what? Come another, you have to build the X is unknown, T is unknown, Y is 0, no problem. So build up another equation. Try to build up another equation to correct this, to solve this. Again take rod AB, take the rod AB, take moments about A. If you take moments about A, what is that? R, T available, R and T and W, ne? For rod AB, this B exerted by the flow, R, this R exerted by the flow, right? For rod AB, take moments about A, R there, W there, T there. You can find the T. Once you know the T, you know the X. Or otherwise, for rod AB, come about B, takes about B. For rod AB takes moment about B. then x there, t there, w there. Y is 0 ne? Then you can get another equation x and t. That's too much because too long. You know x and t are equal. So better write this. For odd AB, for odd AB, for odd AB, take moments about A. Take moments about A, yeah? For odd AB, take moments about A. Complete it. For odd AB, take moments about A. Find the T answer. Then problem almost solved. For that, for AB, moments about A, ne? So can I say the R better than R direction sense, 4Z's are, but the total component 2A sin theta, here 2A cos, 2A sin theta, okay? 2A sin theta, 2A sin theta R, this is 2A sin theta, okay? Next what? W minus the R that side, W other side, ne? Minus W, line of action here. This one or that, here A cos theta, A sin theta, right? A sin theta, A sin theta. What about T? T, midpoint ne me petta. T anit petta ne? T the opposite direction, opposite, other side, right? Minus T. So minus T into the direction, this one, distance, this one. A cos theta, right? Is the line of action, T line of action. A cos theta, right? A cos theta equal to 0. So you know R. Find the T therefore. Divide by sign also, divide by sign. 2R, cut the A. Minus, divide by sign. T cot theta divide by sin W, ne? Divide by A sin theta, divide by A sin theta, A. What is 2R? 2W. Simplify therefore. T cot theta equal W. Therefore your tension in the string is what? W tan theta. Okay, important problem. W, this is the question of these days. Simply they exams or they see. W tan theta, right? Tension force in the string. W tan theta. So that's the x. That is the x. X equal to t. Therefore that's the x. Therefore x equal W tan theta. Therefore x equal W tan theta. Then give the reaction at A. Therefore reaction at A. What is reaction at A? Square root of x square plus y square. You know y is 0. Therefore that is x neither. Answer is W tan theta. W tan theta is the answer. But the direction horizontal, because x direction, that is horizontal. Next question, 2020 problem. they provide the diagram A, B, C, D. AB weight is W, BC weight is lambda W, and CD is 2 lambda W, 2 lambda W. Interesting question, simple problem, right? Here alpha, angle. Draw this figure. Here alpha. Draw the figure here. Here there's a force applied horizontally. I read the question. You can see. And something here also they marked the arrow, I think pulled somewhere. So draw this nice diagram, clearly show this AB, BC, CD and D there, 2 lambda W, everything. Okay, so quickly hadadamu api ivara wenda kalin hadamu. Draw the figure. Draw diagram. Okay, see, I read the question, what they said here. 3 uniform rods, right? A, B, B, C and C, D. Each length is 2A. Each length is 2A. Smoothly joins at B and C, right? B and C. The weights of the rod AB, W, BC, lambda W, other one 2 lambda W. The ends A smoothly hinged fixed point, they are hinged, right? Fixed point. The rods are kept in equilibrium vertical plane by a light inextensible string attached to the C. There's a string, therefore tension force here, right? There's a by a string they told that, tied that. A force F applied, force P is applied to the end D, such as AC are same horizontal level. This AC, ANC same horizontal level, same level, they say same level, this same horizontal level, right? ANC. The angles are shown that. Show that lambda 1/3. Prashna really end on lambda is 1/3 and show lambda is 1/3. Show also the horizontal vertical component exerted on AB by CB. On AB by CB කියන්නේ මෙතන අහනවා B, X and Y or anything component අහනවා. Find those. Show also the horizontal vertical component here. W by 3 tan alpha, W by 3 tan alpha and W by 6. That's the question. W by 3 tan alpha and W by 6. Show these two components the B, right? Says the question, start the work. So first we show all the forces. Length is provided, all 2A length. Therefore here A, right? A. Here no any symmetrics, no any symmetric. Here B. Can I show some forces here? At B there's a hinge. There's a hinge at B. We mark the forces at B. Vertical, horizontal components. I say horizontally X. Here I mark another X here. And say upward Y. The downward here Y. Also method hinge. So at the hinge, study problem by problem, improve your knowledge. The hinge at A, it has two components, vertical, horizontal component. Can I say one is here R and here S or anything you can write, right? It's the completed force diagram I mentioned. So now they ask, according to this data, show lambda equal 1/3. Show lambda equal 1/3. Here we have T also, vertical T also available, right? So what the most if any in applied maths, if anything has to show that, prove that, you try to do one quantity, two methods and equate. So maybe here T or anything you can find two methods to equate, you can get the answer. So what the method here? See, lambda comes this side, now lambda is available here, not here, right? Therefore, 4 rod CB, see 4 rod CB. He also joint, here there's a joint. He also we have component. Therefore, make avoid current. You can't show this, make a netu. So to remove this or to avoid this or to neglect this, may force a system. So can I take BCD? So earlier 3 questions I shown for only 1 rod moments. Here I give systems moments ganna 2 rods. Can I take for BC and CD? take BC and CD moments about B gamuda. For BC and CD takes moment about B, then you have P, you have this T, you have this lambda W, and there's a chance for T and lambda, that part, ne? We'll see. So write this part, write this. For the rods BC and CD, 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 take moments, BC and CD take moments about B, takes moments about B, take moments about B. For BCD, take moments about B. For the system BCD, right? For BCD, take moments about B. See how that your first equation comes T into and lambda W, 2 lambda W. So B, which one can I take that T, that direction like this T, that direction T, okay, that T, okay, T, that direction T, force is T, what the distance? 2A sin alpha, 2A sin alpha, right? 2A sin alpha, 2A sin alpha, right? T 2A sin alpha minus lambda W, you know here alpha, here also alpha, right? But there is A sin alpha, right? A sin alpha, T that side, W minus ne, arine, A sin alpha, and here what 2, this one I took by B, opposite the same, make a money, minus 2 lambda W, this is from here say, hurry is complete distance, what is that? Here what? 2A, very important, see where final paper, very important here, 2A sin alpha, 2A cos alpha, 2A sin alpha, right? And what is this part? What is A sin alpha, right? 2A sin alpha, A sin alpha, 3A sin alpha, very important. 3A sin alpha, right? Moments to the 2W force to the point B, right? This is the line of action from here to here, completely distance 2 lambda W into 3A sin alpha. What about P? That force also available. But this question, P also passes through, passes through B, huh? P also passes through B. P also passes through B, won't there. So equal to 0. Find the T here, find the T here. Sin alpha cancels, so the sin alpha out. Sin alpha cancel. Okay. So if we stop video, stop the night will I'll show this answer. Try karla balanda. 2 hours ke dala tiyena, just 4 minutes tiyena. Quickly hadamu. Cut day. Therefore T2T equal lambda W, that is 2 6 the 7 then 7 lambda W is it 7 lambda W yes Mahadua. Therefore T answer 7 lambda W over 2, right? This is your first equation. This is T answer, right? T equal 7 lambda W by 2. Therefore, you know T answer. You know the T answer, no problem now. Now the idea is if there's lambda equal that. So jointed rod problem, the idea, we have to solve all the joints. We have to resolve all the joint, find the x value, find the y value, or tension value, T. That's the method, right? Okay, now come. Again we can take this system. See this system come with the BCD. Or if you take the rod BC vertically up T, the Y, T and Y, or the same. See, the T belongs to both rods. This T belongs to both rods. Both rods. Otherwise we call T by 2, T by 2. දෙකටම හරියට බෙදනවා ඉතින් පස්සෙම ප්‍රශ්න හදන්න. එහෙනම් මේ දෙකම ගමු. Once again take that completely BCD. ඒ දෙකටම අරගෙන ගමු T. Right, next. For the system B, for the rods BC and CD, for rod BC and CD, for rod BC and CD, for rod BC and CD, resolve up resolve current. According to my diagram, I put Y down. T minus Y minus W equal to 0. For these two rods, here 2 lambda W available. See here under final paper, last paper equal to 0. T up, Y down. Okay, Y is down. W lambda W, 2 lambda W. So find the Y answer in this case. What is your Y answer? Find the Y. You know T answer 7 lambda W by 2. Y answer 7 lambda W by 2. Okay, minus 3 lambda W. 3 lambda W. Therefore, answer is comes Y equal 6 lambda W by 2. Y answer completed. Check value lambda W by 2. The lambda W by 2. Lambda W by 2. Okay. Now we find the x value. Quickly now we find the x value. Under for rod AB, take moments about A. For rod AB, take moments about A. For rod AB, take moments about A. X there, Y there, W there. Okay, you know the Y answer, then you can find the X answer. Next, write for rod AB, take moments about A, For rod AB, take moments about A. For rod AB, take moments about A. So this direction X, can I write that motion X? This side X, force is X. X into, what is that X into, what is 2A cos alpha, right? 2A cos alpha, right? X into 2A cos alpha, X into 2A cos alpha. I put Y is up, minus Y, 2A sin alpha, minus Y, 2A sin alpha. You know W component here. That is the same direction, my same direction. Here alpha, same direction. They are positive, the plus W, A sin alpha, check value, equal to 0. Find the X value, put the Y and find the X value. Put the Y and find the X value. Majority sin alpha, cut by sin alpha, 2x cot alpha, 2y, what is 2y, lambda w, 2y is lambda w, 2y is lambda w, right? 2y is lambda w plus w ne is okay, 0. Therefore x answer is, take the w out, lambda minus 1, the lambda minus 1 by 2 tan alpha, is it? Check, will you? X equal w by 2 lambda minus 1 the tan alpha. Okay, that. Right. Now see, now we can complete, I think, this remaining part. Okay, see that. Now see this joint, you know x, you know y. You know the x value, you know the y value. For rod BC, take about C. For rod BC, C, when moments gamu. X into something distance, y into distance, w into distance, not w, lambda w. You know x, you know y, you know weight. There's the equation, you can find the lambda. You can find the lambda, the idea, right? Take the rod BC, for rod BC takes about moments about C, right? Takes moments about C. Then you know x into, what is x into 2a cos alpha, x into 2a cos alpha. I think y also are patta menava, y into 2a sin alpha plus lambda w into a sin alpha. Lambda w into a sin alpha equal to 0, right? You know x answer, you know y and a to substitute current, you can find the lambda. You can find the lambda. You can find the lambda value. Show also horizontal vertical component A, B, C, B at B. X, Y. So after getting lambda, after get the lambda, the lambda age dala balanda y enava x enava. That's the answer, complete karaganda. So this is the part of jointed rod. We'll see some more in the future. So this evening we'll see that maximum, minimum tools, few questions to complete. Okay, then lesson is over. We'll see next evening, hour 7 to 9, right?